Okay, Algebra 1. These are our Chapter 3.4 notes, graphing functions. One way to understand a function is to graph them. You can graph a function by finding output values that satisfy the functions. We're going to have two different types of graphs here. We're going to have discrete graphs and continuous graphs. Our key ideas for these two graphs is that for a discrete graph, we'll solve for y. Then we'll use given values of x. That's the key there, given values of x. We'll plug it in and find the y values, and we will plot those points on the graph. For continuous graphs, again, we solve for y. That's not different. But in this case, we're going to choose values of x. We will plug those in to find the y values, and we'll plot on the graph and connect. So there's the difference. Here we have an example. We're going to graph this function for the given domain. If we're given a domain, that means this graph is going to be discrete. So here I'm going to solve for y. The way that I'm going to do that is I'm going to add 2x to both sides. So I have the equation y equals 2x plus 3. And I'm going to take these domain values that I'm given, and I'm going to plug them in. So -5, -3, 1, and 4. So I'm going to go ahead and do that. Okay, as you can see, I took my domain values and I plugged them in to the equation. I took the x out and put the domain value in each equation, here, 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 and here. And I have these output values. So this makes my ordered pair as follows. And I'm going to go ahead and graph those points, and we'll see what that looks like on the graph. I'm going to go to -5 on the x-axis, and I'm going to go down to -7, which will give me a point right here in this area. And then I'm going to go to -3 on the x and -3 on the y, which will be here. 1 and 5, which will be here, and my last point 4 and 11, which is here. Okay, this is a discrete graph because we were given the domain, so we will not connect these points. Our next example, we have a function given we're going to have the given domain of all real numbers. Okay, so the given domain of all real numbers. That means we get to choose which numbers we decide to plug into our equation. Let's see, I'm going to choose the numbers -2, -1, 0, 1, and 2. I'm going to go ahead and plug those in, and we will see what numbers we get out for our ordered pair. Okay, as you can see, I plugged in the numbers I decided to use. I plugged them in right here. And I got these output values that create our ordered pair. Okay, so from here, I'm going to go ahead and plot these points on our graph. -2, -8, -1, -5, 0, -2, 1 and 1, and 2 and 4. Okay, because we have the domain of all real numbers, and we chose the x values that we plugged in, we're going to go ahead and connect these dots. Okay? The next thing we need to remember to do is we need to use arrows on both ends of our line to indicate that the graph continues for the domain of all real numbers. All right? If we don't have that arrow, then we're not including any of the x values after where the line ends. So we have to make sure we put those arrows on there. Okay, for example 3, we're going to be finding values using the graph. So we're going to use the graph of the function y equals -1/2 x plus 4 to find the value of f of x when x equals 4. Key thing to remember here that f of x is the same thing as y. So what we're really asking is, what is my y value when x equals 4? Okay? So let's figure out what my y value is when my x is equal to 4. So I'm going to go over to my graph, and I am going to find where x equals 4 right here, and I'm going to go up to my graph, the graph that's on my grid here, and I'm going to look at that point, and I'm going to go over, and I'm going to see what my y value is. So my y is equal to 2. not y. My y is equal to 2 when my x is equal to 4. Okay? So that means my f of 4, when I plug in 4 as my x value, that gives me the output, or the y value, of 2. Okay, I'm going to use the graph of f of x equals 1/3 x plus 2 to find the value of x when f of x equals 3. All right, so that means, remember, f of x is the same thing as y, and we know that my f of x is equal to 3. So where my y equals 3, we need to find the value of x. So going to my graph, I'm going to go up where my x value is equal, or excuse me, my y value is equal to 3, and I'm going to go across till it touches the graph, which is right about in this area. And that means my x value is 3. Erase my question mark there. I can answer my question now. My x is equal to 3 when my y value is equal to 3. Okay? How can we check our answers? Well, we can take those numbers and we can plug them in to see that it actually satisfies the equation. So let's do that real quick, and you can take a look, and I will have proven it. All right, here we go. Here's my proofs. For our first one, we said that f of x equals 2 and x equals 4. So we plugged in 4 for x here. And we found out that my y value, or my f of x, equals 2 when my x value equals 4. For letter B, we said that x equals 3 when my f of x, or my y, equals 3. Put this here, y equals 3. So we took our f of x away, or our y away, and we plugged in 3. And we solved for x. And here you can see we found that x also equals 3 when y equals 3. That's it for this section.